Mechanical conveying, weighing and dosing. Many types of conveyors are required to move stocks through the milling process. The weighers and dosers are located at multiple points in the milling process to measure and control the rate of these movements. In this chapter, you will learn about mechanical conveyors, weighers, and dosers. Mechanical conveyors. There are several types of conveyors found in a mill. Each conveyor type is suited to different applications depending on the material conveyed, capacity, energy requirements, and accuracy. Spouts are the simplest form of conveying. Spouts convey grain or flour downwards using gravity. The less free-flowing the material, the steeper the spout must be to keep the material moving. Sometimes spill boxes are used to deliberately slow the stock. Fast-flowing wheat from above hits against the wheat in the spill box and exits with less energy. The spill box prevents the abrasive wheat wearing equipment or entering a machine too quickly. Screw conveyors are generally used for conveying grain or flour horizontally or sometimes up shallow slopes. They are used chiefly over short distances. And usually for medium capacity applications. These include conveying from grain silos, from flour bins, or as flour collection conveyors below spouts. They are sometimes used to mix material, for example in flour collection conveyors. This design is a simple screw in an auger, where the purpose is simply conveying. A screw with a continuous ribbon may be used. Where the purpose is both conveying and mixing, a discontinuous screw may be used to increase the mixing action, such as in flour collection conveyors. As the screw spins, the product slides downhill against the ribbon of the screw, propelling the stock forward. Chain and belt conveyors are generally used for conveying grain horizontally over long distances where a high capacity is required. For example, moving grain from an intake point to the silo elevators. A belt or series of links in a chain form a continuous loop. The chain or belt carries the grain in one direction and drops the grain at the destination. The empty belt or chain then cycles back in the other direction. Bucket elevators convey grain vertically upwards and are generally used in high-capacity applications. These include elevating grain to the tops of silos and wheat bins. Buckets are attached along the entire length of a belt, which is driven by pulleys. The grain is scooped up by the buckets at the bottom and unloaded or tipped out at the top. Buckets must be regularly checked to make sure they're still properly attached to the belt. Grain at the bottom of bucket elevators may accumulate and not get flushed through. So bucket elevators must be checked and cleaned out periodically to prevent infestation. Weighers. Inaccurate weighing on dosing can result in severe problems for a mill. For example, loss in future sales due to delivery of underweight or overweight goods, inaccurately mixed goods, or out of specification flour due to inaccurately dampened wheat. Weigh bridges weigh trucks before and after unloading grain. The difference in weight determines the weight of the grain. Weigh bridges are large platforms suspended on load cells. The truck must be at a complete stop before taking the reading. Batch weighers are a relatively accurate way to weigh grain or flour. They often calculate flow rates, but some types are used for other operations. Some examples of their use include measuring the amount of wheat sent to silos, grain bins, or roller mills. They are used where accuracy is essential, such as for weighing additives to pre-mixes. Batch weighers measure flow rate by collecting a batch of the material and stopping the flow temporarily while an accurate weight is taken. The materials are then removed so that a subsequent batch can be measured. The time taken to collect each batch indicates the flow rate. The process following a batch weigher must withstand receiving material in dumps or batches rather than in a continuous flow. Some weigher designs do not dump the batch at once. Instead, they weigh material in such a way that the flow rate into and out of the weigher is equal. Some have similar designs to batch weighers. Other designs range from simple deflection plates to conveyors on load cells. Doses. Weighers measure weight or flow rate, but do not control these things. In contrast, doses control the flow rate to a predetermined setting. Volumetric doses control output rate by controlling the volume of material outputted. Volumetric dosing is usually used for simple dosing operations where low accuracy is acceptable. Some examples of this kind of use include dosing out grain from silos or dosing out flour from flour bins for homogenization. Examples of volumetric doser designs include simple screw conveyors or rotary seals which control flow rate by controlling rotation speed. The faster the rotation, the larger the volume that gets dosed out. However, variations in material density can lead to inaccuracies. If the material density changes, even at the same rotational speed, the weight of the material per unit of time also changes. Gravimetric doses, in contrast, are less affected by changes in material density because they're dosed based on weight rather than volume. Examples of their use include mixing operations or dosing flour to fill flour bags. Some designs use scales to measure flow rate based on weight lost over time. Flow balancers use a deflection plate to measure the flow rate. A slide above the deflector plate varies the flow based on the target deflection.